Rain falls gently outside your window. A breeze cools your skin. You check the weather forecast and plan your day accordingly. You think this is normal. You think weather is something you can predict, something you can survive. You're wrong. Earth's weather can be violent. Hurricanes, tornadoes, blizzards that bury cities. But compared to what exists beyond our atmosphere, Earth's worst storms are barely a whisper. There are planets in our universe where the weather doesn't just threaten life, it makes life impossible. These aren't worlds, they're cosmic execution chambers, natural death traps, where the atmosphere itself is a weapon. We're about to visit 7 of the most hostile planets ever discovered. Places where rain isn't water, where wind doesn't cool, where the very concept of weather becomes something alien and lethal. And as we descend through these worlds, from the merely deadly to the absolutely incomprehensible, I want you to remember something. These planets are real. They exist right now. And they remind us that Earth isn't the cosmic standard. Earth is the miracle. Let's begin with a planet where precious gems fall from the sky.
HD 189733b orbits a star 63 light-years from Earth. From a distance, it looks almost inviting, deep blue, like Earth's oceans captured in planetary form. But that blue isn't water. It's the signature of silicate particles suspended in the atmosphere, tiny fragments of glass scattered throughout the air, reflecting blue wavelengths of light. And it rains sideways. The wind on HD 189733b reaches 7,000 kilometers per hour. That's nearly 7 times the speed of sound. And those winds are carrying glass, molten silicate droplets condensing in the upper atmosphere, cooling as they fall, becoming razor-sharp particles moving at hypersonic speeds. If you were somehow placed on this planet, you wouldn't have time to comprehend what's happening. The wind would hit you first, faster than any tornado ever recorded on Earth. And embedded in that wind, billions of glass shards, each one moving with enough velocity to penetrate your body instantly. You would be flayed, stripped to bone in seconds, and those bones would be sandblasted to powder by the relentless barrage of glass moving at speeds that turn particles into bullets. The temperature here is roughly 1,000 degrees Celsius, hot enough to melt aluminum. The atmosphere is thick with vaporized metals, and through this toxic, superheated hell, glass rain falls horizontally, driven by winds that never stop. But as horrifying as this sounds, HD 189733b is merely our introduction, a glimpse of what's possible when weather becomes weaponized. It gets worse.
800 light-years from Earth, there's a planet called WASP 76b. It's a hot Jupiter, tidally locked to its star. One side faces eternal day, the other eternal night. The day side reaches temperatures of 2,400 degrees Celsius, hot enough to vaporize iron. And that's exactly what happens. On the day side, iron doesn't exist as metal, it exists as vapor. Gaseous iron mixed into the atmosphere, carried upward by thermal convection. Powerful winds move this vaporized metal from the day side to the cooler night side, where temperatures drop to around 1,500 degrees. And then it condenses. Iron rain. Droplets of molten metal falling from the sky, each one glowing orange-red, each one several thousand degrees. The clouds themselves would be metallic, shimmering with the heat of vaporized iron. If you stood on the Terminator line between day and night, you would see something no human eyes were meant to witness. Behind you, a star so close it fills half the sky, heating the ground until it glows. Ahead, darkness. And in between, where you're standing, the sky would be raining liquid iron. The air would be thick with metal vapor. Each breath would sear your lungs with superheated iron particles. The temperature would cook you before the iron rain ever touched you. But if you somehow survived those first seconds, the rain would finish the job. Droplets of molten iron, each one hot enough to ignite organic matter on contact. They wouldn't just burn you, they would splash across your skin, spreading like napalm, melting through flesh and bone. And this happens constantly, day and night, an eternal cycle of vaporization and precipitation, iron rising as gas on the day side, falling as liquid on the night side, over and over for billions of years. But we're only beginning to understand how hostile planetary weather can be. Koros 7b is a rocky planet orbiting so close to its star that its year lasts just 20 hours. The day-side temperature reaches 2,500 degrees Celsius. The night side drops to -200 degrees. And the weather here doesn't just involve one element, it's a nightmare of geological precipitation. On Koros 7b, it rains rocks. The extreme heat on the day side vaporizes the planet's surface, not just metals, everything. Sodium, silicon oxide, calcium oxide, magnesium oxide, all of it boils into the atmosphere as gas. These vapors are carried by convection to higher, cooler altitudes, and there they condense, not into liquid, into solid particles, into pebbles. The clouds on Koros 7b are made of rock vapor, and from those clouds it rains stones. Small at first, grains of sand, but as they fall through the atmosphere, they accumulate more material, growing larger. Some reach the size of hailstones, others the size of gravel. Imagine standing beneath a sky that's raining geology. Pebbles falling at terminal velocity, hundreds of them, thousands, impacting the ground with enough force to crack stone, enough force to shatter bone. But the pebbles aren't the worst part. The air itself is toxic, filled with vaporized rock. Each breath would coat your lungs with microscopic particles of silicate. You would suffocate on stone dust while being pelted by falling rocks in temperatures hot enough to melt lead. And when those pebbles hit the ground, they don't stay there. The surface is so hot they vaporize again, rising back into the atmosphere, condensing, falling, an endless cycle of geological weather. This planet is proof that weather doesn't need to be atmospheric in the traditional sense. When temperatures are extreme enough, the ground itself becomes part of the weather system. But this is still tame compared to what's coming. We need to return to HD 189733b, because there's something about this planet I didn't tell you yet. The glass rain is only part of the horror. HD 189733b is being slowly destroyed by its star. The intense radiation is stripping away the planet's atmosphere at a rate of roughly 600 million kilograms per second. The planet is bleeding into space. But before that atmosphere escapes, it's being superheated to tens of thousands of degrees. The upper atmosphere is so hot that atoms are being ionized. Electrons are being ripped away from their nuclei. The air is becoming plasma. And this plasma is being blown away by stellar wind at speeds exceeding 400 kilometers per second. So the complete picture of HD 189733b is this: a planet where glass rain falls sideways at hypersonic speeds through an atmosphere being heated to plasma temperatures while the entire planet slowly evaporates into space. You wouldn't just die here, you would be simultaneously flayed by glass, incinerated by plasma heat, and torn apart at the molecular level by stellar radiation. There would be nothing left, not even atoms, just ionized particles scattered into the solar wind. This is what happens when a planet exists too close to its star, when gravitational forces and radiation become so intense that the planet itself cannot hold together. And yet, impossibly, this still isn't the worst weather in the universe.
Kelt 9b is the hottest exoplanet ever discovered. It orbits a star 670 light-years from Earth. The dayside temperature is 4,300 degrees Celsius. That's hotter than most stars, hotter than 70% of all stars in the galaxy. At this temperature, molecules cannot exist. Water molecules would be ripped apart into hydrogen and oxygen atoms. Iron would be vapor. Even the planet's atmosphere is being torn apart at the molecular level. Kelt 9b is so hot that it's destroying itself. The intense heat causes the atmosphere to expand dramatically. The planet is larger than Jupiter, but less dense than styrofoam. It's a bloated, dying world being cooked by its own star. And the weather here isn't rain or wind or storms, it's atomic chaos. Atoms are being ionized continuously, electrons stripped away by thermal energy and radiation. The atmosphere is a sea of charged particles, a plasma so hot and dense that it behaves more like the interior of a star than a planetary atmosphere. If you were placed here, you wouldn't burn, you wouldn't melt, you would dissociate. The molecular bonds holding your body together would break instantly. Your cells, your DNA, your atoms, all of it would be ripped apart. You would become plasma, indistinguishable from the atmosphere itself. And this is happening to the entire planet. Kelt 9b is losing its atmosphere at an estimated 10 billion kilograms per second. The planet is evaporating. In a few 100 million years, there might be nothing left but a scorched core. This is a planet being killed by its own star, and the weather is the weapon. But we haven't reached the absolute limit of planetary hostility yet.
HD 80606b has the most extreme temperature variation of any known planet. It follows a highly elliptical orbit around its star. At its farthest point, the temperature is around 400 degrees Celsius. Hot, but not unprecedented. But every 111 days, the planet swings close to its star, very close. And in just 6 hours, the temperature rises from 400 degrees to 1,200 degrees. That's an increase of 800 degrees in 6 hours, faster than any thermal change observed anywhere else in the universe. The atmosphere doesn't have time to respond. The sudden influx of energy creates shock waves that propagate through the gas at supersonic speeds. Atmospheric pressure spikes violently. Winds accelerate from calm to thousands of kilometers per hour in minutes. And then, just as suddenly, the planet swings away from the star. The temperature plummets back to 400 degrees. The atmosphere contracts. The winds reverse. This happens every 111 days, a thermal shock so violent it would tear any solid structure apart. If you were on HD 80606b during one of these close approaches, you would experience something beyond description. The sky would brighten rapidly as the star swells in size. The temperature would climb at more than 2 degrees per minute. Your body would try to cool itself through evaporation, but the air temperature would exceed your internal temperature within an hour. At that point, your body can no longer shed heat. Your core temperature starts to rise. Proteins denature, enzymes stop functioning, cells begin to die. But you wouldn't live long enough to experience the final stages of hyperthermia. The atmospheric shock waves would hit you first. Pressure changes violent enough to rupture your organs. Winds strong enough to lift you off the ground and hurl you into the superheated air. And then, if anything remained, it would be incinerated by the peak temperature of 1,200 degrees. This planet doesn't have weather, it has thermal convulsions, regular, predictable cataclysms that make the surface uninhabitable during every orbital period. But even this extreme violence pales in comparison to our final destination. WASP-12b is not just being killed by its star, it's being devoured. This planet orbits so close to its star that it completes an orbit in just one Earth day. The gravitational forces are so extreme that the planet is being stretched, deformed into an egg shape. The dayside temperature exceeds 2,500 degrees Celsius. The atmosphere is thick with vaporized metals and carbon compounds, and the planet is so bloated that its atmosphere extends beyond the Roche limit, the distance at which tidal forces overcome gravity, which means the star is actively pulling the planet's atmosphere away, consuming it. WASP-12b is losing 10 billion tons of mass every year. The material is being drawn into an accretion disk around the star. The planet is being eaten alive. But before that atmosphere is stripped away, it experiences the most extreme weather conditions known to science. The tidal forces create massive atmospheric tides, walls of gas hundreds of kilometers high, moving across the planet as it rotates. The temperature differential between the day and night sides drives winds of unimaginable violence. And the atmosphere itself is toxic beyond measure. Carbon monoxide, water vapor at plasma temperatures, metals in gaseous form. All of it superheated, all of it in constant motion, all of it being slowly pulled away into the star. If you were placed on WASP-12b, you would experience something unique in the universe. You would feel the planet dying beneath you. The ground would be molten, the sky would be glowing with heat. The star would fill half the horizon, close enough that you could see detail on its surface, close enough that solar flares would arc directly over your head, and you would feel the pull, the tidal force trying to lift you off the surface, the same force that's pulling the atmosphere into space, the same force that will eventually tear the entire planet apart. This is a world in its final days, a planet being slowly dissolved by gravity and heat. And the weather here is the atmosphere screaming as it's torn away into the void. This is as hostile as planetary conditions can possibly be, a world where the weather is planetary death itself.
We've journeyed through 7 worlds where weather is not measured in rain and sunshine, but in glass shards and molten iron, in falling rocks and molecular destruction, in thermal shocks and atmospheric evaporation. These planets are real. They exist right now, orbiting distant stars, experiencing conditions so extreme that our language struggles to describe them. And here's what they teach us. Earth is not normal. The gentle rain that falls outside your window is a cosmic rarity. The breathable air, the stable temperatures, the magnetic field that shields us from radiation, the distance from our star that allows water to exist as liquid, all of it is improbable, fragile, balanced on a knife's edge of conditions that allow life to exist. We think of Earth's weather as powerful, as dangerous, hurricanes that level cities, droughts that crack the ground, blizzards that freeze entire regions. But compared to the universe at large, Earth's weather is gentle, nurturing, safe. Out there, beyond our atmosphere, weather is a force of annihilation. It's glass moving at hypersonic speeds. It's iron rain falling through metal clouds. It's rocks precipitating from stone vapor. It's atmospheres being heated to stellar temperatures. It's thermal shocks that rewrite the surface conditions in hours. It's entire worlds being slowly devoured by their own stars. And the terrifying truth is this: these hostile planets are probably more common than Earth-like worlds. Most exoplanets we've discovered are hot Jupiters, tidally locked scorched rocks, or gas giants in extreme orbits. Worlds like Earth, with stable climates, liquid water, protective magnetic fields, and gentle weather, might be the true anomalies. So the next time you complain about the rain, or curse the heat, or shiver in the cold, remember, you're experiencing weather that allows you to survive. Weather that is, in cosmic terms, impossibly kind. You're standing on a planet where the sky doesn't rain glass or iron
or molten rock, where the wind doesn't strip your flesh or tear apart molecules, where the atmosphere isn't being pulled away into space. You're standing on the miracle world. And perhaps that's the most unsettling realization of all, that we exist in a universe where planets like Earth are so rare that we might be utterly, completely alone. Not because life is impossible, but because the weather on almost every other world won't let it survive long enough to ask the question.